I wanted to go over the types of reactions again, and so I made this recording. The first question here is a combination reaction, and we write a balanced chemical equation for the following reaction, and so we have this here. What I'm going to do is tell you to pause it, and then you can work on it and then play again to see me work it out. Okay, so write a balanced chemical equation for the following reaction. Okay, and you can pause it now. Okay, so I gathered you hit play. And when you have a combination reaction, okay, you have to remember you have one product. Okay, one product. And so what we would do is we would look magnesium. Magnesium is in group 2A, and so therefore has a +2 charge. Oxygen is in 6A. It's going to gain 2 electrons. So it's going to have a -2 charge. So the product will be MgO. Okay, we have to make sure that the total net charge is 0. +2 plus a -2 is equal to 0. And then we would balance the equation. Well, we have 2 on this side. We put 2 oxygens here. That gives us 2 oxygens, but it also gives us 2 magnesiums. Now let's go to the next slide. Here it is balanced. Okay, so this is the balanced chemical equation for this particular combination reaction. Next example, write a balanced chemical equation for the following decomposition reaction. When we have a decomposition reaction, we have one reactant, okay, one reactant, and we'd have 2 or more products. Okay? And in this one here, you would just write the equation and then balance it. Again, it's decomposition. So if you want to work on this, let me just change that to B. Okay, so you can pause. Okay, so let's look at the answer to this. Okay, we'll look at the answer. We have the products. We would have silver, and we'd have oxygen. Remember, oxygen is one of those Brinkel, B-R-I-N-C-L-H-O-F. These are all diatomic when they are standing by themselves, and so oxygen would have to be O2. Now, silver is a metal. It can be by itself. So we have 2 oxygens, 1 silver. Here we have 2 silvers, 1 oxygen. If we put a 2 here, that gives us 2 oxygen and 4 silvers. So then we have to put a 4 there. Ammonium nitrate. If we look at the table 9.3 on page 257, we see ammonium, NH4, has a +1 charge. Nitrate, NO3, has a -1 charge. So ammonium nitrate would be this, NH4NO3, would give us dinitrogen, 2 nitrogens, monoxide, 1 oxygen, plus water, H2O. And then we have to make sure it is balanced. Okay, and I have it right here. Here we have a total. Here we have to add the 2, so we have 4 hydrogens here, 4 hydrogens here, 2 nitrogens, 2 nitrogens, 3 oxygens. 1, 2, 3. Okay, this 2 means we have 2 waters. So now this is balanced. Okay, and again, decomposition. With decomposition, we have one reactant, and then breaks down into a simpler substances. Single placement reaction. Here we have to use the activity series of the metals to write a balanced equation, chemical equation for each single replacement reaction. I have two examples here. I have two examples here, and I have here this activity table. So if we look at this, again, when we have a single replacement, we either switch the same the cations, or if we have anions here, we would switch the anions. This is a cation, this is a cation, so will be a cation, okay? It would have a form a cation. So you can put it on pause. And work on it. Okay, I assume you hit play. Let's take a look at silver. We have silver, and that will form a positive charge. Potassium is +1, nitrate, NO3, be a -1. So these are going to try to switch. But let's see if they can. Here we have silver, and here we have potassium. So silver has a lower reactivity than potassium. Potassium can replace silver, but silver cannot replace potassium. So in this example, there's no reaction. No reaction. Okay, the next one, we look at aluminum. Aluminum is in group 3A. It will form a +3. We have hydrogen. We have two hydrogens, and then a sulfate. Sulfate is -2. And again, we could look on page 257. That table 9.3, that would help us with sulfate. Okay, so we're going to have these switching. Well, let's take a look at aluminum. Aluminum here and hydrogen here. So aluminum can replace hydrogen. Okay, aluminum can replace hydrogen. So to finish the equation, and let's move this out of the way here. Okay, so we have aluminum and SO4. We have to make sure the total net charge is 0. And if we look, we maybe do this little thing here. SO4 is a -2. It'd be -4. Aluminum is a +3, so it's not balanced yet. If we have aluminum, two aluminums, that's a +6. And we have 3 sulfates. So this would be the formula. Plus we have hydrogen by itself. Okay, and then we have to balance the equation. Okay, so we have 2 aluminums here. We need a 2 here. Now let's do that in another color. We have 3 sulfates. Okay, we have 3 sulfates on the right. If we put a 3 there, that gives us 3 sulfates on the left, but that gives us 6 hydrogens, so we need a 3 here. Okay, so we have 2 aluminums, 6 hydrogens, 3 sulfates, 3 sulfates. So now it's balanced. Okay, we have that here. This is the answer here. Okay, double replacement reaction. Here we have 2 compounds, and then we're going to have 2 compounds. So write a balanced equation for the following double replacement reaction. It gives us a hint. It tells us cadmium sulfide is a precipitate. So if you want to put it on pause and work on it. Okay. So let's take a look. We have cadmium sulfide as a precipitate. Let's just give us some room here. Okay, let's break this down. We have two bromines. Okay, bromine is a -1 charge. We have two of them, so that means this cadmium has to be a +2 charge. We have sodium, which is going to be +1. Sulfide is going to be a -2. And then we have forming cadmium sulfide. So these two are going to be switching. So let's move this out of the way. Cadmium is a +2, and sulfide is a -2. Well, we don't really need that 2 there. And so that would be cadmium sulfide. Again, we determined that. If we look at this, cadmium is +2, sulfide is a -2. You add them together, it equals 0. Okay, and so we have that. And then we're going to have, and she said it was a solid. So we have cadmium sulfide, and then we have sodium. These two are going to be together. Sodium, let's put this, sodium and bromine are going to be together. We put the sodium first, because it's a cation, and the bromine second, sodium bromide. Okay, and so that would be the skeleton equation. It's not balanced. If we have 2 sodiums, and we only have 1 sodium here. If we put a 2 here, that gives us 2 sodiums and 2 bromines. So we have 2 sodiums here, 2 bromines here. We have 1 cadmium, 1 sulfur, and so this is balanced. Now let's take a look at it here. Okay, balanced equation. Okay, the last one is a combustion reaction. Remember, combustion reaction, it always produces carbon dioxide plus water. Always produces carbon dioxide plus water. Okay, and then to balance it, if we have, let's move on. If we have x equals 2, y equals 6, okay, so we have C2H6 plus, this would be x, which is 2 plus 6 over 4, that's O2, gives us 2 CO2 plus y over 2 for the coefficient of water. Okay, and so again, it's just algebra after this. 4 cannot go into 6 evenly, so we're going to have to do a little more math. So we have 8 over 4 is 2 plus 6 over 4. So 2 gives us 2 CO2 plus 3 H2O. Okay, so we add this, C2H6 plus 14 over 4, O2 gives us 2 CO2 plus 3 H2O. We want to get rid of this 4 here, so we have to multiply everything by 4. So it'd be 4 C2H6 plus 14 O2. Okay, remember the 4 times 14 over 4. The 4's cancel out. 4 times 2 is 8 CO2 plus 4 times 3 is 12 H2O. And it looks like we could divide everything by 2. So we have 2 C2H6 plus 7O2 gives us 4 CO2 plus 6 H2O. Okay. So this is how we would balance this equation. Again, a little bit of math. And that's what we have here. Okay, so those are the samples I wanted to go over again, give you a little bit of practice.